Just a second, sir. Yes, sir. Now you can start the session, sir.
Good morning, students. So last time we have discussed about organic. Okay. So let's continue with the organic portion. In last class, we have discussed about the bond line notation and condensed formula, structural formula, and what exactly you can say homocyclic compound, heterocyclic compound. We have all discussed that thing. So now, according to the hybridization, we'll see some characters, and you have to remember, you don't have to go that much deep in this particular topic of S character and all, but just remember the main point so that you can do the question answer easily. For example, okay, we right now I'm considering only three hybridization: sp3, sp2, sp. Basically you can have a shortcut. If single bond is present, then sp3, double bond is present, sp2, triple bond is present, sp. If a condition like this will occur, this will again have sp hybridization. Most of the time you can use this trick. So just check. I'll tell you how to check best. We have discussed the hybridization in the portion of chemical bonding also. We will discuss here also, but later on. Right now we have to concentrate about the IUPAC today, just because it's a long session, and I have to concentrate on the IUPAC. And I'm hoping that you know the basics. So if you don't know, if you're not getting anything in the mid, so I'll go from the starting again. Okay, so this is a base. So today I'll first start with the hybridization. So if I'll go for the hybridization, what is the S character in sp3? What is the S character in sp3? 25. sp2, 33.33. sp, 50%. How many people are there in the meeting? Okay, so in case of this hybridization, we have to calculate the percentage of the S character. So this is the percentage of S character. What you have to remember. Now, first thing you have to remember that percentage of S character is directly proportional to the electronegativity. Is directly proportional to the electronegativity. So now tell me, which one is more electronegative? sp, sp2, sp3? Fast. Anyone?
SP, sir.
sp, yeah. Because sp is having the more S character, then we'll go for the sp2, then sp3. Okay. Second thing what you have to remember, that percentage of S character is inversely proportional to the carbon-carbon bond length, and percentage of S character is again inversely proportional to carbon-hydrogen bond length. The more S character will be there, the lesser will be the bond length. Now tell me which will have the smallest bond length. I'm saying if S character will increase, bond length will decrease. Now tell me sp, sp2, sp3.
SP, sir.
sp again same thing. See, in the S character we have in sp we have S character more 50%. So if 50% of the S character is present, it means the S character is more, so bond length will be shorter. So sp again, then sp2, then we'll go for the sp3. Okay, third thing, bond strength. Anyone? Just correlate the percentage of S character with the bond length. See, you can say if bond length is small, then if bond length is small, bond if bond length is small, then bond strength will be higher. Now tell me which one will have higher bond strength. Anyone fast? I'm saying bond length will decrease, bond order will increase. See, bond length is inversely proportional to the bond strength. If it will increase, another one will decrease. So
SP
now I'm
only,
saying,
sir.
yeah, very nice. SP will have more bond strength because 3 bonds are present. sp2 will have lesser strength, then I will go for the sp3. And the last one, what you have to remember is percentage of S character, of S character. Okay, can anyone tell me about the acidity? Okay, I'm saying percentage of S character is directly proportional to the acidity. Percentage of the S character is directly proportional to the acidity. So now tell me which one is more acidic. Which one is more acidic? A, B, or C? See, I told you the shortcut. This one. If triple bond is present, sp. So here triple bond sp. Here double bond sp2. Here sp3. Now tell me, which one is more acidic? A, B, C. Which one?
A, sir.
A. So just speak fast. Okay. Now first tell me the hybridization only. Okay. I'm giving you some compound. First tell me the hybridization. CH2 double bond NH. What is the hybridization of carbon over here? Double bond. If double bond is present, hybridization is
SP2.
sp2. So carbon is here. sp2 hybridized. Okay. Now tell me hybridization in this case. Okay. This is carbon number 1. This is carbon number 2. Carbon number 3. Carbon number 4. Okay. Carbon number 1. Hybridization. See, double bond O is present. Double bond
SP2.
S2, sir.
sp2.
So,
Carbon 2. Second carbon
SP3, sir.
sp3. Third carbon
SP3.
again sp3. Fourth carbon
SP3.
sp3. So this is basic. So just tell me which of the 4 carbon. Okay, which of the 4? Like we know that C2, C3, C4 is sp3. I'm talking about now which one is more acidic. C1 versus all. C1. In this condition, S character is more. Percentage of S character is more. It means the acidity of the compound will be more. So that particular carbon, that particular hydrogen have more acidic character. Okay. Now BF4. Hybridization of B. Hybridization of B. Just check the number of bonds. All are
sp3
similar. sp3. Very good. Okay. Last one. Nitrogen.
sp3
sp3. So this is quite basic. So just remember S character. First thing, S character is more, electronegativity of the compound is more. S character is less, the bond length will be more. If bond length is increasing, the bond strength will increase. No, bond length is increasing, the bond strength will decrease. And if percentage of S character is more, acidity will be more. So these are the quite small things and not a big thing. No, that you are not remembering. Okay, let's move further with the classification we have done. So now one topic is homologous series. Homologous series. What homologous series is? It's simply a series of compounds having the similar features. You can say. See, what is series of compounds with similar properties and successive members differ by CH2 group or 14U or by 14U, that is atomic mass unit. Okay, so I'm saying 14U, CH2 carbon mass is 12, hydrogen mass is 1, 2 hydrogen is present, so it will be 12 plus 2 is equals to 14. That's why I'm saying it as 14U. Okay, so we can take one example of alkane series, basic. First example, CH4, then C2H6, then C3H8, C4H, 10, C5H, 12, C6H, 14. You can go further. I told you in the last class how you have to do the member or how you have to name the formula of every member in this family. So now in this particular homologous series, you can see the if you'll minus any of the, like for example, I'm C3H8 minus C2H6, it will be equals to CH2 only. So every member of this particular series is differing by the CH2 group, and now you can say that this is a homologous series because I've mentioned in this definition that series of the compound with similar properties and successive member differ by CH2 group. These are the members which are which differ by the CH2 group, and these are known as homologous series. Their chemical properties, physical properties will be same. Okay. So sometimes we also have the functional group family. We have some functional groups. So for example, I'm talking about CH3OH, C2H5OH, C3H, C3H7OH. The sort of this family. If you'll minus any of the compound, they will again differ by the CH2. And all of these compound will show the alcoholic property. Reaction will be due to carbon as well as OH group. So those series in which the successive member are differ by the CH2 group or 14U and showing the physical and the same physical and the chemical properties. So they are known as what? Homologous series. See, homologous series, first point what you have to remember that they have this difference of CH2 group, or you can say 14U. Second thing, you can say that they have the similar functional group. Third thing, you will say that they have the similar chemical and physical properties. It can be melting point, it can be boiling point, it can be density, etc. So these are the characteristics, basic characteristics of the homologous series. What are functional group? What are functional group? Anyone? See, what are functional group? See, in the left side you can see a book, and yeah, these are atom or group. What atom or group? That determine the chemical properties. That's it. I'll show you this book PDF also later on. But first, just revise this. Okay. Whatever I'm teaching in the class, that is main important. So, what I said, what are functional group? These are the atoms or the group which are attached with the chain. Atoms or groups that are attached with the chain of carbon and determine their properties. Determine their properties. Okay, so for example, you can say we have OH alcoholic group, we have CHO aldehydic group, we have COOH acidic group. Which group is known as COH? Carboxylic acid or carboxylic nowadays. And we have COOR, that is esters. We have nitrile, C triple bond N, we have nitrile. We have SH, that is thiol. So we have certain examples: COCl, COCl, that is, okay, what is COCl? Acid chloride. Then A, that CONH2, that is amide. Then NH2, that is amine. SH, that is called thiol. So we have more functional groups. I gave you approximately, I think, 6, 7, 8, 9, 10 examples, but we have more. So at least remember these functional groups. These are the most important functional groups. Okay. So let's move with the nomenclature of the compound. Okay. So let's start with the nomenclature of the compound. Color palette is good. Okay. Nomenclature of the compounds. Organic compound. Okay, what do you mean by nomenclature? Anyone? What is nomenclature? That is naming something. See, when you were born, your parents give you a name just to recognize you, whatever you are, and uh, whenever you'll go out, people call you by that particular name. So that is basically the nomenclature. Okay, so organic compounds are in varieties. We have you can say billions of organic compounds. So that for that sake, what we need to do, we need to give them a name. For example, if I'll say acetic acid, so you must know that I'm talking about the vinegar, CS3COH. If I'm talking about formic acid, that you must know about HCOOH. If I'm talking about acetaldehyde, you must know I'm talking about the CS3CHO. So these are the compound common names. Okay, so according to that, nomenclature was assigned to organic compounds, and basically we have two type of systems. First one is trivial system. Trivial system. Second one is IUPAC. You can say IUPAC. Okay. So what is trivial system? It was the oldest system in which the naming is done on the basis of source, some property, or maybe some other reason will be there. So basically these things are there. So quite frequently the name was chosen from either Latin or Greek word. So we have two type of nomenclature. First one is the trivial, in which the naming is done on the basis of source and or the some property of the compound. So the name was taken on the basis of Greek. So if I'll go more deep in this particular, I can give you some examples like acetic acid. Acetic acid in Greek, in Latin is known as acetum. There's a word acetum which means vinegar, and acetic acid is also known as vinegar. So it was taken from a word that is called acetum. Okay. Formic acid. Formic acid is taken from the word that is called formicus. Formicus was a word which was denoted for red ant. For red ant, we take a name that is called formicus, and this is a Greek word. Third example, you can say oxalic acid. Oxalic acid word is oxalis. Malic acid, the name is Pyrus malus. Then citric acid, the name is citrus. So these are botanical sources from where we are getting it. Okay, so these are the names which were see, I told you, either from the source or from the Latin words or the Greek words. So these are on the basis of biological sources. So basic example you can take of this citric acid. Generally the fruits or the things which are literally sour in nature, generally they contain they are known as citrus. This is family citrus, in which you get citric acid. Okay, so this was all about the trivial system. But what about IUPAC? So if I talk about the IUPAC is full form of the IUPAC is International Union of Pure and Applied Chemistry. So IUPAC is the system of nomenclature was developed in 1892, and these system contain a systematic order in which the name should be given to the given to the compound. So we have to discuss the main IUPAC, not the tribal system. But just remember whatever I taught you in this tribal system, that is only important, nothing else. Okay. So first thing that is we have to learn under the IUPAC is the root word. I think all of you have done in class 10th. I'm writing the number of carbon. You have to tell me what is the name. C1, C2, C3, C4, C5, C6, C7, C8, C9, C10, then C11, C12, C13, C14. Then we'll go for C15, no, according to your book, I'll go. C14, then we'll go for the C20, C30, C40, C50, C60, then C100. At least 10, probably you know. So just tell me fast. C1, C1,
Neet.
just say it, meth. Second, eth. Then third one,
Prop.
prop. C4,
Butane.
bute, only bute. C5,
Pent.
Pent.
pent. C6,
Hex.
hex. Very good.
Hexa.
C7,
Sept.
Hept.
hept. C8,
Oct.
Oct.
C9,
None.
non.
Deck.
Non. Then C10 is deck. C11, undeck. C12, dodeck. C13, trideck. See, that's just you have to do. Un means one, do means two, tri means three, C4 4 for tetra. It will be tetradeck. Like you can go same like hexadeck, heptadeck, octadeck, nonadeck. Okay, that's not a big deal. C20 is known as ICOS. Then C30 is known as tricon. C40 is known as tetracon. C50 is known as pentacon. C60 is known as hexacon. C100 is known as hectane. Okay, so these are the root word of IUPAC. Just take a screenshot fast so that you can, when I'll do the nomenclature, start the nomenclature, you can do that. If you want to write it, just write it fast. At least after 11, just write. So that you can go simultaneously. Whenever I'll give a compound, you can write it. Okay, so just do it fast. Done? Okay. Next. So after root word, we have two things. First one is suffix. Okay. And another one is prefix. Suffix means whatever we are writing at the end. So suffix is again classified into two categories. First one you can say primary amine or primary suffix. Second one you can say secondary suffix. So in primary suffix, you have to indicate this is used to indicate whether the compound is saturated or unsaturated. Whether the compound is saturated or unsaturated. For example, in saturated, you have to add ane. If unsaturated, with there will be a possibility of double bond or triple bond, you have to, in the case of double bond, you have to add ene, and the triple bond, we have to add the ine. Okay. See, in case, I'll go prefix later on. First, let's discuss this suffix only. In case, if two double bonds are present, in case two double bonds are present, you will use diene. If three double bonds are present, then you'll use triene. 4, then you'll go for tetraene. Okay, so you can do like this. If n number of double bonds are present, then you'll use polyene. If two triple bonds are present, then you'll use diene. Three triple bonds are present, you'll use triene. Same polyene if you'll go for n number of. Okay, so this was the all about primary suffix. What are secondary suffix? Secondary suffix are those compound which tells about the particular functional group. That tells about the particular functional groups. For example, if you'll see, alcohols are there. So alcohol functional group is OH. Secondary suffix will be all. For example, you can see we say as ethanol. So if I'll divide this particular word eth plus n plus all, eth represent 2, n represent single bond, all represent alcohol. So this is a root word, this is primary suffix, this one is considered as secondary suffix. Clear? Another example we can take of aldehyde. Aldehyde functional group is CHO. Secondary suffix is al. Now we can take another example of ethanol. Divide eth plus n plus al. Now tell me, eth represents 2, n represent single bond, an represents single bond, al represent aldehyde. So again, we have two type of suffix. First one is the primary suffix, which tells about the saturation of the compound, while the secondary suffix tells about the particular type of functional group. If the functional group is not present, only the primary suffix can also work. So if the secondary suffix is not present, name should be like hexane, heptane, octane. So we have ane, acid. You can say octane or decane. Okay, so now we can also tell this, but we have hex represent 6 carbon, ane represent the saturation, hept represent a single compound, again ane represent the saturation, oct represent the 8 compound, ane represent the saturation, oct represent the 8 carbon, but ine represent the triple bond. Here dec represent the 10 carbons, but ane represent the single bond. Dec represent again 10 carbon, ene represent the double bond. So primary suffix and secondary here we don't have any secondary suffix, but the primary suffix is sufficient to tell about the property of the compound. Okay, so till now any problem? See what we have discussed. First, just revise it once. I'm telling, first we have discussed about the S character, then we some sort of hybridization, then we have discussed the homologous series, then we have discussed the functional group, then the nomenclature of the compound, the tribal system I have discussed, and then we have discussed about the IUPAC. Certain example of this is the example of tribal system. Then we have go for the IUPAC root words. Then we have gone for the suffix, primary suffix and secondary suffix. Primary suffix classification, saturation and saturation. Secondary suffix represent the functional group. Then we have taken the examples of primary, secondary suffix with the root word. Okay, so till now, if you have any problem, just ask me. And if this is clear, then let me know. Any doubt till now?
No, sir.
Anyone else? No? Okay. Remember one thing. While writing secondary suffix, you have to remove E from the last. From the last, you have to remove the E. For example, in AN, just you'll write AN. In EN, you write EN. In IN, you will write YN. So you have to remember the C. In case of, for example, I'm writing ethanol. Eth plus N plus all. I have not mentioned E. Okay. So while writing the secondary suffix, so you have to remove the E from the last. From alkene, alkene or alkyne. Done. Let's move further with the prefix. What is prefix? First thing, prefix tells about the cyclic nature. If the compound is cyclic or forming any kind of ring, then we generally use cyclo in the starting. So if I'm writing like cyclohexane or I'm writing like cycloheptane, so it means these are having a ring. So second, this prefix tells about the cyclic nature of the compound. Second thing, it tells about the substituent. Substituent present on the parent chain. What are the substituent? For example, if any of the substituent, chloro is Cl is present in the chain, so it will tell about the substituent. Okay, so again, prefix is classified into two categories: primary prefix, secondary prefix. What is primary? Primary represent the root, you can say root word or cyclo, if cyclo is present or not. Okay, for example, I'm having a compound that is this. So we have 1 carbon, 2 carbon, 3 carbon. So while writing the name, first I will write cyclo plus 3 carbon is there. So for 3 carbon, what we use? For 3 carbon, what we use?
Probe, sir.
Probe. All the single bonds are present, so it will be ane. The name will be cyclopropane. Okay, so primary suffix tells about the cyclic nature. But what about the secondary prefix? Anyone, any idea? See, certain functional groups are present which are not considered as functional group. Which are not considered as functional group. So they are generally added in the case of, they're not generally added in the name, and they are considered as secondary suffix. Okay, so let me tell you one example. Okay, the example is like CH3, CH2, CH3, CH, here Br, CH2, CH2, OH. So this is a compound. So here, this is the functional group. This is the functional group. But what about Br? Br is considered as secondary. Br is no. Here Br is considered as suffix. Okay. For example, let me write the name. It will be 1, 2, 3, 4. 3 bromo, 4 carbon, butane. OH is present at the butanol. 3 bromo butanol. So I'm writing the names like this. So see, the primary prefix I have not added just because this compound is not cyclic in nature. But secondary suffix like bromo I have added just because Br is not considered as the main functional group. So you have to write it in the starting of the parent chain. Okay, so this is the rule. Clear? Any doubt? No.
No, sir.
Okay. So let's start with the questions. Okay. First, what you have to remember, but first is like basic nomenclature. I think you know. First, I'll give you some basic nomenclature, then we'll move for the further bigger compounds and certain rules. You know, I think what is the first rule? You have to select the longest chain. Okay. First, you have to select the longest chain, then you'll go for the if functional group is present, then you'll do the numbering from the side where the functional group is nearer. From where the functional group is near, you have to do the numbering from that particular side. Okay. In case of side chain, what you have to do, count number of carbon, assign a root word, and at last just add YL. For example, C, 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 and here one side chain is present. So number of carbon is 1. So number of the root word assigned is meth. And last what you have to add YL. It will be methyl. Okay. For example, C, 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 C. Here we have C2H5. So we have 2 carbon in the side chain. The root word assigned is eth. And at last what you have to add YL. That is called ethyl. Okay, so you have to do the numbering like this. Clear? So let's discuss about some rules. Rules for the nomenclature. Then we'll go for the example. So first nomenclature rule is select the longest chain. Select the longest chain. Okay, so CH3CH, here we have CH3, CH2, CH2, C. Okay, now let me take us some typical example. CH3C, CH3, CH3, CH2C, CH2, CH3, here CH3, and here again CH3. Now tell me, from where the longest chain is present? See, if I'll go like this, 1, 2, 3, 4, 5, and 6. Don't you think that I'm getting the highest number of carbon? Getting my point? Yes or no? If I'll go straight, if I'll go like, okay, I'm doing 2 type of counting. 1, 2, 3, 4, 5. Which one is correct? Green one or red one?
Red one, sir.
The red one, just because the number of carbons are present in the chain is more. So the first rule of the IUPAC is that you have to select the longest chain. So first you have to do the longest chain. Okay, I'll do something. I'll give one more example. The example is CH3CH, CH2, CH3, CH, CH2, CH3, CH2, CH2, CH3. So one is 1, 2, 3, 4, 5, 6. Another one is 1, 2, 3, 4, 5, 6, 7. Okay, which one correct? Red or green?
Green.
Here green is correct, just because we are getting the number of carbon more. Okay, so just first rule is you have to select the longest chain with the number of carbon atom is more. Okay, let's start with the second one. What is the second one? Second one is the position of the substituent. Position of the substituent. Okay, for example, see, I'm taking this nomenclature from literally the bottom. So if you don't understand anything, just let me know. So which one is the correct order of nomenclature? Writing, giving the position.
Second one, sir.
This is A, this is B. Which one?
Second.
B.
B. What
B,
does
sir.
the rule say? That you have to do the numbering from the side from where the substituent is nearer. So this one will be considered as correct. Clear? Okay. So one more, third rule. See, lowest set of locant I'll let you know later. Okay, first we are going for the basic rules. In case third is presence of more than one same substituent. If more than one same substituent is present, then what you will do? For example, size CH3, CH, CH3, CH2, C, CH3, CH3, CH3. From which side should I do the numbering? Left side or right side? From left side.
Right side, sir.
Right side. Confirm.
So we should begin from left side.
No. We have to do the numbering from the side from where the maximum number of substituents are present. If same substituent is present, okay. For example, if I'll go from, see, I'm doing two type 1, 2, 3, 4, 5. There's one possibility. Another possibility is 1, 2, 3, 4, 5. Okay, so if I'll go for both of the compound, which one is correct is this blue one, and the red one is considered as wrong. Why? Because from the left side, CS3 group is on the same side, or from the right side, if you will say CS3 group was in the same position, they both are present on the second position. But if I see on this particular side, we have two CS3, one CS3 above, one CS3 down. So we'll give priority to that particular CS3. Why? Because di, tri, tetra compounds are present here. Okay. So remember, if same substituent are present, then you have to do the numbering from the side from where more number of CS3 groups are present, more number of substituent are present. But what in case of substituent which are different? Okay, so let's start. Fourth case is in case of different substituent. See, here we were having only CS3 and CS3. But what will happen when there is a substituent different? Then what you will do, see, making a compound. Okay. First of all, let's discuss in the first case. Any idea? See, this one is ethyl. This one and this one is methyl. And this is the main chain. But from where should I do the numbering? Main question is from where should I do the numbering? The numbering should be done right side.
Right side.
From right side, because CS3 is nearer. Because the CS3 is nearer. Even if they are having the same function, we are having a different substituent, we'll see the position. So we'll do the numbering from the right side. 1, 2, 3, 4, 5. Clear? Done? Okay. In second example, first of all, the longest chain is 1, 2, 3, 4, 5, and 6. And I think this is follow the same order also. Yeah. We have to do numbering from this particular side. Just because CS3 and CS3 are near. If we'll go from the back side, it will come on the fourth position. This is coming on the third position. No, this is coming on, these both are coming on the third position. So the numbering should be done from this particular side. So just remember, in case of same substituent, if the number of substituent is more on the same carbon, that you will do the numbering from that particular side. But if the substituent are different, but then you'll see the substituent which is more close. Okay. Now tell me. Fifth rule. In case of substituent at equivalent position, it means the alkyl groups are present on the equivalent position. For example, CS3, CH2, C2H5, here C2H5, then CH3, CH3, CH2, CH3. Now check and tell me from which side should I do the numbering?
Right side, sir.
Eh? From right.
Yeah, sir, I think from right side.
Okay, so here we again have one rule. First, second, third. If I'll go from the left side, it will be 1, 2, 3. If I'll go from the right side, 1, 2, 3. Now what will happen? The rule says that if they are present on the equivalent position, From the left side, if I'll see the substituent is on the third position. If I'll see from the left side, the substituent is on the left position. So what we will do in this particular case, we will write the name of the compound in which this which will come in the nomenclature first. So this is ethyl, this is methyl. So alphabetically the naming is done. So in alphabetical order, if E is coming first and M is coming at the last, so I'll do the numbering from the left side. Got my point? Or should I again repeat? Fast. Speak it up. If you're not getting my point, I'll repeat it again. I say I'm repeating. See, on either side of this particular compound, we are getting the substituent on the equal position. From left side is on third position. If on the right hand side we have in the third position. But how I will write the name? I will write the name of the compound which is having the first letter alphabet. The first alphabet is present in the alphabetical. We have to do the number. We have to do the naming in the alphabetical order. So in this particular case, if you'll see, ethyl have E, and E comes first in the alphabetical order. So I'll do the numbering from the left hand side. Okay, just if I'll make a mirror image of this particular compound, I'm giving you one more example, same like this. Okay, you have to tell me from which side should I do the numbering. Wait. I've made this mirror image of that particular compound. Now tell me, from which side should I do?
Right side, sir.
Right side, because ethyl
Right
is coming
side.
from the right side now. So I think you got my point, what I want to say. Okay. Next rule, number 6. Naming of the complex. Naming of the complex. So I'll give you one more example. CH3, CH2, 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 CH, CH2, CH2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here we have CH, CH, CH3, CH3, CH3. Now, how you will do the numbering and naming? How you will do the numbering?
Right side.
Right,
Numbering.
sir.
From right side. Why?
Then we get minimum number, sir.
Confirm. Okay, from right side, you want 1, 2, 3, 4, 5, I think. And if I'll go from left side, 1, 2, 3, 4, 5. So I can do numbering from any of the side. Just because this side chain is coming on the 5th position from the all side. So I can go for any side. So it's not left, it's not right, because it is coming on the equivalent position from the both side. But how I write the name? So this particular thing is a complex substituent. So I'll do the numbering in such a way that I'll name this substituent, this side chain, complex substituent. Okay. So for that, I'll start from the position from where it is bonded with this carbon. So I will like 1, 2, 3 carbon is present. First, I'll write the name. Okay. So on the first position, methyl group is present. On the second position, methyl group is present. So it will be 1, 2, 1, 2 dimethyl 1, 2 dimethyl. Okay. 1, 2, 3. 1, 2, 3 carbon is present. So I have to write propane. But since this full compound is under the category of side chain, I will write propyl. And I will put that in bracket. So I have named this particular compound first. Now I have to mention the name 1, 2, 3, 4, 5, 6, 7, 8, 9. Or else you can do from the right side because it's on the mid. So how I can write the name? See, the name will be on the 5th position. This particular compound, this substituent is added. So I will write 5. Then I will write a dash. Then I'll use parenthesis. And then I'll write 1, 2 dimethyl propyl. Then I'll close up the bracket. Then I will write the number of carbon present in the main chain, that is non. And all single bond is present, so it will be nonane.
Nonane.
Clear?
Yes, sir.
I'll give you one example. You have to tell me the name. Okay. The example I'm giving is like, see. Three, four, five. One, two, three, four, five. Then 6 CH2, then 7 CH. CH2 single bond. CH3, then CH2, 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 CH3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Now, do the numbering and tell me the name. I'm giving you 2 minutes. Done? Yes? Okay, time's up. You can check your answer. I'm doing the nomenclature. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Name of this compound. We have earlier done the 5th position. That is 1, 2 dimethyl. No dash. Sorry. 1, 2 dimethyl propyl bracket 1, then 7 ethyl. How many carbon is present? 11, so it will be undecane. Anyone who is correct?
I got till ethyl, but I didn't write aldecane.
You haven't mentioned undecane.
Yes, sir.
Rest it was correct.
Yeah, sir.
Very good. If it is correct and you're doing this for the first time, there's complex one.
No, sir. We have completed this one in school too, sir. Not this one,
And
like this time.
yeah. So if you have done and still it is incorrect, then you have to practice. Rest, if you have done this much, this is good. This is not easy. Okay. One more example, let's take. Just because this is the complex one, we have to do this. So I'm writing one more example. CH3, CH2, 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 C, CH2, 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 and then CH3. Here C, CH2, CH3, then CH3 here, CH3, here CH2, CH single bond, CH3, then CH3. Write the name. Two minutes again. So this is the practice we have to do together. Done. Okay. Let's start doing this. Okay, so numbering, left side, right side. Right side. 1, 2, 3, 4, 5. I think same. 6, 7, 8, 9. If I'll go from the left side, right side, the same thing will be there because the substituent are added on the same position. Okay, just first, what I prefer is just write the name of substituent in rough. So first, if I'll write the name of this substituent, this will be 1, 1. See, 1, 2, 3. 1, 1. Okay. Dimethyl 3 carbon, then propyl. Okay. If I'll go for the second one, it will be 1, 2, 3. In second position, we have 1 methyl. So it will be 2 methyl propyl. Okay. So if I'll do the numbering, we both have here we have methyl, here we have methyl. Okay. But since we have D over here, we have ton of monkeys over here in my house. So they are just jumping and creating sounds. Okay. So we have D over here, and just because of D, we will write the name of this substituent first. 5. Check your name. 1, 1. Di. Very good. Dimethyl. Then propyl. Bracket close. Then dash 5
2
2
methyl propyl.
methyl propyl bracket close nonene. So the name
Sir,
is 5 1 dimethyl propyl 5 methyl propyl nonene.
sir,
Yes.
is it necessary to we write bond 5 after the dimethyl propyl?
Pardon. It is necessary for what?
It is necessary to write the 5 after the dimethyl propyl. I mean, I write the 5-1 dimethyl propyl dash 2 methyl propyl and
Why?
nonene.
No. You have to write. You have to mention again. You have to mention like this.
Okay, sir.
This is necessary. Yeah. You cannot
That's
merge
what,
them.
okay,
Yeah.
sir. That's what the whole thing I did.
The rest was good.
Yeah, sir.
Okay. Should I give one more example? Just try. CH3, CH2, CH, C2H5, C, CH3, then CH2, CH2, CH, over here CH3, then CH2, CH2, CH3, C, CH3, CH3, CH3. Okay, just try. Then I'll tell you one more rule. Two minutes for this example. Done. Okay, I'm writing the name. Check your name. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have 10 carbon in the main chain. Okay, first I'll do the name inside 1, 1 dimethyl ethyl. So 1, 1, clear? And 2 carbon is there, then I'll write ethyl. Okay, substituent is, I think only one substituent is there, so that's easy. So then we have to write the name. In A, B, C, D, we have D first. Okay, just remember you have to make it capital here. Die. Okay, the naming should be 3, 1, 1 dimethyl ethyl, then dash. On third position, we have one more ethyl,
Hi.
3 ethyl dash. On fourth position and on the seventh position, these two are
Methyl.
methyl. So it will be 4, 7 dimethyl, and number of carbons are 10. So it will be
Decane.
Decane. So the name is 3, 1, 1 dimethyl ethyl 3 ethyl 4, 7 dimethyl decane. Yes. Who is wrong here now? Everyone is correct. Literally. Yes, Bhavna. Bhavna? She's in the class or she left?
She's not
Okay.
there.
She's not there?
Yeah. I think there is some network issue with her.
Okay.
Yeah.
Okay. So anyone else? If any problem? Okay. So these are the basic things. What you have to remember is organic. Okay. So let's do one more example of this complex type. See, we have to do a ton of example in next 3 days also. I'll go for the nomenclature on this just because the nomenclature is the main part. If you will not know the nomenclature, then you won't be able to do the naming ever. So I'm telling you from basics till I go with the advance. CH3, CH2, 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 CH 1, 2, 3, 4, 5, 6, 6, then 4, 5, 6, and we have to add over here like CH2, CH, and we want CH3. Here CH3, then CH2, CH, CH2, 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 CH3. I think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 carbon there. 2, 3, 4, 5. Here we have to add CH, CH2, CH2, CH3, and here we also have one CH3. Okay, write the name. See, just remember, if you are doing mistakes, this you are trying. Means that you are trying. If mistakes are happening, it means you are trying. If mistakes are not happening, it means you are not trying. So you have to try. It's okay. Everyone do mistakes. There was a quote that is a little progress each day adds up to a big result. Okay, so if you'll do a jump from a lower level to the high energy level, then there is a possibility you'll fall down. But if you'll do a little progress day by day, it means you are learning daily. You are practicing it daily. So there's a possibility that you'll have a big result in one day. So just do a little progress, just do a little learning, revising, doing questions on the base will give you a big result. So don't care about your result right now. Just concentrate on your studies. Revise as much as you can.
Sure.
Done?
6.
6.
Yes.
1, 2, 3, 4, 5, 6, 7. Okay, I'll do them. Okay. I'm doing the numbering. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Yes.
Okay.
7 2-methyl.
First, I think you have to go for the fifth one.
Okay. 5-1 methyl.
Okay, I'm writing 5, 1, methyl. Then,
Close the brackets.
if we don't have the main chain. See, 1, 2, 3, 4. You have mentioned one methyl.
Butane.
Butyl also. Okay. Then rest. Then dash.
7
7. Then dash.
2-methyl.
2 methyl. Very good.
Butyl.
Butyl. Yes. Bracket close.
And 12th one, it will.
What we say 12? Dodec. And all single bond? Dodecane. So this was the name. Very good. Next. See, sometime what exactly happened? The same substituent present on the same group. Then what we have to do, we have to add. See, if two same complex is present, then we will use bis. If three substituent is present, we'll use tris. If four substituent is present, then we'll use tetrakis. Okay, so on the basis of this, I'm giving you one example. Okay, so if the same substituent is present, then you have to mention the. So I'm doing one example, you'll do another example. You'll do practice. Okay, or else I need to search an example for you right now. CH3, CH. Here we have CH3, then CH2, then CH2, then C. 1, 2, 3, 4. C, CH3, CH3, CH2, CH3. Then here C, CH3, CH2, CH2, CH3. Then CH2, CH2, CH, here CH3, then CH3. Okay, let's remove this one. CH2. Number of carbon is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, one more I need to add. CH2, and here last one is CH3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The fifth one, 1, 2, 3, 4, 5. Okay, write the name of this one. Let me search one more example. No, getting any book right now. Okay, done?
Yes, sir.
Okay, check. 1, 2, no, not from here. From the left side it will be 1, 2, 3, 4, 5. See, on the fifth position, if you'll see above and below, same group are present. The name is 1, 1 dimethyl, but
Propyl.
methyl and propyl. So this is the same group is present on both of the side. So let's write the name. So it will be 5, 5 on the fifth position above and fifth position below. Bis, because two substituents, same substituent are present. Then we'll use bis. 1, 1
Methyl propyl.
methyl propyl. Then dash 2 Methyl. Because on the second position we have CH3. And since we are having 6, 7, 8, 9, 10 carbon, then it will be considered as decane. Clear? Clear?
Yes.
Okay. Let me check one example in this book. So basically, if you want to do more example, then I'll do one thing. Should I give you one? Should I share one sheet for you for practice, if you want? See here also the same example is here. Okay. So if you want me, then I will give. If you don't want, then I'll not give. First, I want your decision. You want to practice more?
Yes, sir.
Yes,
Okay.
sir.
Then I'll provide one sheet for you. Okay. Probably today I'll send after this class. You'll get one sheet. I'll make some compounds and I will send on. I'll give to the sir and sir will provide you. So you have to do the naming, and in tomorrow class I'll definitely check it. Clear? Clear?
Okay. Okay.
Okay. So let's start doing a nomenclature of compounds containing double and the triple bond. Earlier we were doing only the example which were having the single bond. See, all the example were containing the single bond. Now let us start with the compound having the double bond. Okay. Okay. Probably a compound containing double bond. It means we are talking about alkenes. Okay. So let's do example CH3, CH2, CH double bond, CH2. CH3, CH2, CH double bond, CH single bond, CH2 single bond, CH3. CH3, CH2, 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 C double bond, CH2, 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 CH3. One more example, CH3, CH, CH3, single bond, CH2, CH, double bond, CH, single bond, CH3. Okay, first one. I think probably you have done this in class 10th also. First one. How many? See, you'll give priority. In the first example, you'll give priority to the double bond. From everywhere, you have to give priority to the double bond here right now. Okay, tell me. Name of the first compound is? See, 4 carbons are present. 1, 2, 3, 4. 4 carbon, it means bute. Bute. And double bond is present, then you would use suffix as "-ene". On the first position, double bond is present, so you'll add 1 butene. Clear? Let's do another example from, okay, in this second example, I should do from where side I have to do the numbering? Left side or right side?
Right side, sir.
See, from both sides it is equal. So you can do from any of the side. Okay, 1, 2, 3, 4, 5, 6. Double bond is from on the third position, either from the left side, either from or from the right side. Okay, so it means 6 carbon is present. So for 6 carbon, we use a hex. If double bond is present, we'll use "-ene". But the double bond is present on the third position, so it will be 3-hexene. Okay, what about this compound? How you will do the numbering? We'll start
This is
numbering from the place from where the double bond is nearer. So it will be 1, 2, 3, 4, 5, 6. And this will be considered as side chain. Okay. On the second position, a side chain is present. The number of carbon in the side chain is 3. So 3 number of carbons, and then we'll use prop. And in the head of side chain, we use YL, propyl. So it will be 2 propyl. And since we are having the 6 carbons, so it is hex. And since the double bond is present, so it will be ene. The 2 propyl hexene. Okay. Sometime we write like 2 propyl hex 1 ene. So this is also correct, just because we are mentioning the position of double bond. Okay, next one. Name. Left side or right side? Numbering should be done from the right side or left side?
left side, sir.
No, it will be from the right side. See,
Double
you will give
bond.
the priority should be given to the side, double bond, not to the side chain. Okay, if functional group is present, then this is a different thing. But in case of substituent group like CS3, you'll give priority to the double bond. Okay, so numbering should be done from the right side. 1, 2, 3, 4, 5, and 6. On the fifth position, methyl group is present. The 5 methyl. 6 carbon is present. Then hex.
Hex.
On the second position, double bond. Then 2. Then ene. So the name is 5 methyl hex 2 ene. Okay, I'm giving one more example. You have to do it fast. Okay. Example is CS3C single bond, CH2 single bond, CH3. Then we'll go for the CH double, here double bond is present. CH single bond, CH2 single bond, CH2 single bond, CH3. Okay. Now tell me the name fast.
Sir.
Done?
Yes, sir.
Okay. Numbering from which side?
Left side.
Left side, sir.
From this side?
Yes, sir.
Like this 1, 2, 3, 4, 5, 6.
Yes, sir.
Yes, sir.
Now you are wrong. You forgot the first rule. What was the first rule I taught today? The number of carbon must be more in this parent chain. So numbering should be 1, 2, 3, 4, 5, 6, and here we have 7 carbon now. So this is the main thing. Now remember the first rule. What first rule said?
Sir,
What first rule said?
Numbering of carbon must be more.
The number of carbon must be more in the parent chain. This is the parent chain. The number of carbon must be more. So now tell me the name. On the third position, we have methyl. On the third position, we have methyl. We have 7 carbon in the main chain, so it will be considered as hept. On the third position, we have double bond, 3 ene, 3 methyl hept 3 ene. Clear?
Yes, sir.
Okay, let's move further for the next example. CH3 CH Br CH2 CH Cl single bond CH double bond CH single bond CH3. See, a simple thing what you have to remember, that halogens is not considered as a functional group over here. They are secondary substituent, you can say, that you can say they are considered as in the prefix. So the numbering should be given to the double bond. Now do the numbering and let me know the answer. Probably, I think you have done. Yes. Now speed up. 1, 2, 3, 4, 5, 6, 7. See, in alphabetical order. Wait. Br in IUPAC we named it as bromo. In Cl we named it as chloro. Okay. So in alphabetical order, since Br is come first, so we'll write 6. Along with the position, we will write 6 bromo, then dash. On the fourth position, we have Cl. First letter now will be small, just because the first letter of the B is capital. 4 chloro. Next we have 7 carbon, then hept. Then on the second position we have 2 double bond, and then ene. That is called 6 bromo 4 chloro hept 2 ene. Clear? Done?
Yes, sir.
Your answer was same? See, speak. When you'll ask, if you are wrong, you have some doubt, just ask. Okay. One more
Sir,
example. Do the numbering. Done? Last 15 minutes I'll take. Okay. Just tell me the name first. Okay. I'm writing the name. Check. So in this particular case, if I'll do the numbering from this particular side, it will be 1, 2, 3, 4. 1, 2, 3, 4. The double bond is on equal position. So I'll give the priority to the substituent now. So 1, 2, 3, 4, 5, 6, 7, and 8. Now if I'll do the numbering, on the third position we have ethyl group. So 3 ethyl dash 4. No, not 4. On fifth. On 5 methyl. Then we have 8 carbon. It will be oct. Then on the fourth position we have double bond, and then we'll go for the ene. That's because double bond is present. So it was correct or not? Anyone whose answer were correct? Not a single one.
No, sir.
Where was the mistake? And which thing you were confused?
Numbering, sir.
Numbering. See,
Yeah.
just remember the rules say that if the double bond is coming on the equal position from the either side, if you'll do the numbering from the left side, you'll see that it is coming on the fourth position. If you are doing numbering from the right side, it is coming from the coming in the fourth position. So it means that from both the side, the double bond is on the equal position. So now you will give the priority to the substituent. For example, on the third position, ethyl is present. While if I'll do the numbering from the left side or the right side, if I'll do the left side, CS3 is coming on the fourth position, and from the right side, CS3 is coming on the fifth position. So if I have the substituent near, then I'll give priority to that particular order. Okay. So it's okay. Don't worry. See, if you'll not do mistake, you'll not learn. Remember this thing. Okay. Okay. Let's do one more example. This is quite easy, huh? CH3, CH2, CH2, C, CH3, C2H5, then CH2, then C, CH3, CH3, then CH3. You can have CH3. Okay, just leave this one also. CH.
So
Yeah.
2 methyl.
Numbering from which side?
Left side, right side, sir.
Right side. Okay. Then 1, 2, 3, 4, 5, 6, 7. Okay, done.
2 methyl.
Why methyl first? Alphabetical order, we have also ethyl over here. C2H5. In alphabet, E for come first or M come first?
E, sir.
E. So you have to name first ethyl.
Okay, sir.
Now tell.
4 ethyl, sir.
Yes, 4 ethyl, very good. Then
4 methyl.
why again 4 methyl?
So
We
they
have two CH3 now. Then you
Ethyl,
write
sir.
2,
Yeah,
4.
4.
2
Yeah.
methyl.
Bismethyl.
Dimethyl. Because 2-methyl is present, then dimethyl. How many carbons?
7.
7, sir.
7. It
Hept.
means hept. And all single
10.
bond then? 8.
8.
Heptate.
Okay, I haven't mentioned double bond over here. Okay. Clear? Any doubt till now? Let's have a new thing, that is CH3CH, CH3, CH2, CH, double bond C, C2H5, then CH2, CH, then Br, then CH3. C. Now tell me what to do. From left side or from the right side? C, what you have to remember here, if functional group, or you can say double bond here right now, is coming from equal, is coming equal from either side, something equal from either side, then substituent is ignored. Okay, so this is a sort, we can say. So in this particular case, see, BR is CS3 is coming on the second position. BR is also coming on the second position. But in this case, if I'll do numbering from the left hand side, so CH3 to H5, 1, 2, 3, 4, 5. C2H5 is coming on the fifth position when we are doing from the left side. But if I'll do from the right side, 1, 2, 3, 4. Now it is coming from the fourth position. So I will opt for that particular case in which the substituent is coming nearer. Clear what I want to convey you? That in this condition, BR and CS3, they both are coming on the second position. And if I'll see the position of double bond is coming on the equal position. Either you'll count from the left side or else you'll count from the right side. But what is the difference? The difference is that C2H5 is coming on the fifth position from the left hand side, and from the right side, it is coming on the fourth position. So I will prefer to the position which is less. So the numbering should be done from the right hand side. So its name, the name what we will write will be on the second position we have bromine, so it will be 2-bromo 4-ethyl, just because C2H5 is present. Then on the seventh position, see, 4, 5, 6, 7, and 8. On the seventh position, we have methyl, and since we have 8 carbon and oct, then on the fourth position, we have double bond, and double bond, so we will write ene. 2-bromo 4-ethyl 7-methyl oct 4-ene. Clear?
Yes, sir.
Okay. So I'm writing one thing. There's a quote from a person that is called Sam Levison. What he said, that don't watch the clock do what it does. That is, keep going. So what I just want to convey with this particular quote, that don't stop until you complete the thing. See, if you'll see the clock, it always go on. It never stop until unless your cell is weak. Okay. So just consider that cell, that is your mind. If you are tired, you'll stop. Just don't let it be tired. Okay. Just take a particular gap, start doing it again. If you'll do mistake, it means you are trying. So we have certain things, just try again. Once you'll fail, another time you'll fail, third time you'll fail, but at least on the fourth time, I can assure you that you will pass in this particular thing. I know organic naming is not that much easy. So we are on the starting phase of this organic. Since I'm taking the 2-hour class today, so why my intention to take this particular class for a longer duration is so that you can go in a pattern. If I'll make a gap, you'll leave everything today and you'll not be able to revise it today, and you'll not get anything in the next class. So I just wanted to complete this particular thing right now. So remember, you don't have to watch the clock. What do you have to do? You have to do what the clock does. Okay. So till now, revise everything, whatever I taught you in the class. Okay. From the next class, we'll start with the nomenclature of alkynes. Then we'll go for the nomenclature of the compound which are having double and triple bond. So we have certain orders for the double bond and the triple bond. Then we'll go for the secondary suffix. Okay. It means we are talking about the secondary suffix means we are talking about the functional groups. Then polyfunctional group compounds. Then we'll go for the aromatic compounds. So we will take approximately 4 to 5 days. I think I will take class Monday, Tuesday, Wednesday, and Thursday. So all 4 days there will be nomenclature on. So just don't skip any of the class. Try to come in every class and revise daily. Okay. Done? Done? Everyone?
Yes, sir.
Okay. Now let's end up the class. You can join the next session now. Okay. Thank you so much. Have a good day.
Thank you, sir. Students, you can join the next class.